Hello everyone, I am Mageshwari, Assistant Professor, Department of BSc Information Technology at Dr. SNS Rajalakshmi College of Arts and Science. In this video, I am going to discuss about deadlock deduction and how the way we are using the deadlock deduction and how we can avoid the deadlock. Here is an introduction about deadlock deduction. So deadlock is nothing but it's a situation when more than one process are trying to occupy a same resource. So this will leads to a severe problem like the multiple number of resources a process can be weighed for a single resource. This deadlock can be deducted in two different ways. The first one is about single instance, and it is nothing about the resource types are same, but in multiple instance we have a number of different resources with different types. This is about single and multiple instance. We have two approaches for single and multiple instances in deadlock deduction scheme. The deadlock deduction can be if suppose it is a single instance, means we can use a resource allocation graph. In this diagram the resources are nothing but resource 1 and 2. It may be a printer or memory or whatever it is. This is generally considered as resource 1 and 2. The process P1 and P2. Here P1 is assigned for resource 2 and P2 is assigned for resource 1. Here the cycle is formed, that is P2 is assigned for R2 and also it is requesting for R1. Likewise P1 is assigning to R2, also it requests for R1. So here the cycle is formed since no process can complete its task. This type of situation we call it as a deadlock. This can be deducted with the help of deadlock deduction algorithm. Here I am using resource allocation graph, that is simply we call it as a RAG algorithm. In resource allocation we have a table like that. Here the process R1 and R2, P1 and P2. Here P1 indicates that particular process is occupying that particular resource, and 0 represent that particular process is not occupying the resource type. Here P1 uses R1, so I am using the value as 1, but P1 is not using R2, so I am putting here as 0. P2 is using R2, so I am here indicating the value as 1. In this RAG, here this table can be explained in P1 gives R1 and P2 gives R2. R1 indicates P2 and R2 indicates P1. Here cycle is formed, that is from starting as P1 value and ending with the P1 value. If the cycle is formed, we can confirm that particular resource allocation method will cause some deadlock. So in this case we by using this technique we can different resource allocation scheme. That is this table indicates we could not allocate that particular process to the particular resource. Alternatively we can allocate the process to some other resources. If we are doing like that, the resource in the resource allocation mechanism it helps to avoid the deadlock deduction. So it is the main thing in a single instance of deadlock deduction. If suppose it is a multiple instance, we have to check whether the cycle occurs and then identify the process which caused the deadlock, and also we have to identify the resource which can be affected by deadlock. By identifying these things we need to identify the deadlock and try to remove the deadlock and provide the proper resource allocation. It's for single instance. If it is for multiple instance, that means we have a number of process and number of different types of resources. So in this situation we can use a wait for graph. This graph having three attributes: check for cycle, that means before allocating a resource to a process we have to check whether the particular allocation method will lead a deadlock. If it leads some cycle, we could not use that resource allocation, we can use another allocation methods. Identifying the deadlock process, that means which process and which resources allocation will cause the leads the problem of resource allocation, that is identifying the resource process, determining the resource type. Suppose we have a lot of different resources, we have to identify which type of resource can be affected with the help of deadlock reduction. This can be avoided with the help of wait for a graph. Wait for a graph indicates how the remaining process should be weighted before allocating the resource. For example, here R1 and R2 is a resource type, P1 and P2, P3 are the process. During we have a 3 resource but only 2 resource but 3 process. Definitely one process should wait for a resource, so we have to identify which process should be wait and which process should be allocated. By using this technique we can easily avoid the deadlock reduction. In this graph, it starts with the value P1 but it does not ends with the value of P1, so this kind of allocation definitely not affects the cause the deadlock. So we can use either RAG graph or WAG graph to avoid the deadlock reduction. Thank you.